welcome to Chapter 13, Section 5, called Trapezoids and Kites. This is for Integrated Math 1, or IM1. So just to get started here, on the front screen, the first thing you should see is your due date. I don't see that on my teacher preview, but you will see it on your student screen. The second thing is the number of attempts. We always have unlimited attempts on homework, tests, and quizzes. Number of questions just tells you how many are on this particular assignment. Grading policy is always best score, so whichever attempt is the best one is one you get to keep. And partial credit is enabled, so if you answer one of two questions correctly, you get credit for the one question, or however many you answered correctly. This also, if I understand correctly, goes into parts of a question too, if there's more than one answer within the question. There's partial on there too. Down here it says, please remember once you start your homework, you must finish it before you can work on anything else. And what that means is once I click start, down here in the bottom right corner, there's going to be a submit assignment button. This is how we finish an assignment. So what that means on the last screen is you can't work on anything because Alex is going to lock all of your other assignments and even the resources until you click the submit assignment button. What it's trying to do is leave this attempt open for you and not close it. If you say close this screen and you're not done yet, or you close your computer, it's trying to leave the attempt open for you. So just make sure that when you want to leave this screen, whether or not you finished, you click submit assignment so that Alex doesn't lock out all of your other assignments and resources. That's one huge reason to click that button. Another big one is that it actually affects the grade book when you click that button so that your teacher can see what you've been working on and hopefully it will improve your grade there. All right, on the side we always have three resources. We have explanation. Explanation tells us that we're going to lose our current question attempt because it's going to give us the answer to this exact problem. So it's not going to give you the answers unless you come type them in. Example will give you something very similar to what it is we're looking at and kind of walk you through the idea here. Read through background information, especially if you see this section. If you don't see the background information, it's kind of introducing something brand new. That's the idea. So you can scroll through. Once you're happy with that example, you can close it. You can open another example so that you can see another one worked through if you need to. You can also message your teacher directly from the screen so we know where to come help you because it attaches a picture of this problem on the email. So it's a good way to get specific help on a problem. All right, let's go ahead and get started. All right, so now we're looking at a rhombus. So that's got a slightly different equation that goes with it. So to rhombus, we have EF, GH below, EG. So oopsie, dropped my pen. Ugh. EG, which is one of the diagonals here, and I'll try. Oh, it's not a very good rhombus. I'm not terribly good at drawing the rhombi. So we have EG, and I'm just gonna like this, and so that is 28, and then we have FD, which is this guy here, and that's 10. And they want us to find the area of the rhombus. So when we're doing the area of a rhombus, we can do another formula. It's area equals, it's still 1/2, but we don't have a top base and a bottom base. What we're going to do is the diagonals multiplied together. So it's diagonal 1 times diagonal 2, like this, and this is times. So that's 1, 2, just meaning diagonal 1, diagonal 2. It doesn't matter which one is diagonal 1 and which one is diagonal 2. It does not make any difference whatsoever. So we do need to remember the properties of a parallelogram. A rhombus is still a parallelogram. And remember they bisect. So if this half is 10, the top half is 10. So I have the entire diagonal as 20 millimeters, and this was millimeters. I just forgot to put millimeters on there. So I can go area equals 1/2 times 28 times 20. Diagonal 1 times diagonal 2. And if I put 20 times 28, it's not going to make any difference at all. So I could do this. I could simplify first. I could do 28 times 20 and then divide it by 2. But I could do 28 divided by 2 and get 14. And then 14 times 20 is a little easier because I can do 14 times 2, which is 28, and then just add a 0 on the end. So it's kind of a little bit of mental math there. I don't necessarily need to write out the whole multiplication problem if I'm using kind of simplified methods like that. Or I could have done 20 divided by 2 and got 10, and then 10 times 28 is also 280. So either way, you know, I could have gotten there a little easier. Area, again, that's two-dimensional, so it's millimeters squared. All right, so this last one, we're going to be looking at a coordinate plane. And I know when we were doing this in class, I have all three of them on there because you could end up with a trapezoid, a rhombus, or a kite. So by chance they're giving us a rhombus here. I think I'm going to try to do that same thing here where I'm going to snoop around and see if I could try another one and see if we can try all three of them so that you can kind of see the different methods. So we already know how to find the area of a rhombus. So the area of a rhombus is 1/2 Why is my pen doing that? I don't like that at all. Stop being so sloppy. Times diagonal 2. So I need to know what is diagonal 1 and what is diagonal 2. So if I go from diagonal from here to here, it's straight across. I can see that. It's -2 and -2 for the y, which means I didn't go up or down. I'm going straight across. So I just needed to say what is the distance here. From -2 to 6, well I have 2 here and I have 6 more here, so that's 8. And then I'm going to do the same thing here and I can see it goes 2, 2. So I'm going straight up and down because the x coordinates haven't changed. I'm not moving right or left. I'm going straight up and down. So I have 6 and I have 2, so that's another 8. So I'm going to have 1/2 times 8 times 8. So again, I can do half of 8 is 4. 4 times 8 is 32. So it's going to be 32 square units. And in this case, they just didn't tell me, what the units were. So it's just square units if we were to divide this into squares like a coordinate grid. All right, let's see if I try another. Ooh, trapezoid. Yay, they gave me a trapezoid. So with a trapezoid, its area equals 1/2 times the height times the bases added together. So I need to know what's the height here. So if I'm looking at the height here, I just want to know if I'm going from this point up to this line, what would the distance be? So I want to know the y here is -7. If I go up to the y on this one, it's -2. So that means that's a distance of 5. And I could do the same thing here. If I'm going from -7 to -2, I'm going straight up. That's 5 units. A, which we'll just do, the top one here. So I'm going across. I want to know what changes. I'm going from -8 to 6. So I have -8 and then 6 more. That's going to be 14. And then B is the other base. So I'm going from -4 to 2. So it's 4, 5, 6. What? It's doing it again. Stop doing that. Pen is being wonky here. Okay, so I'm going to add these together. And I know that's a little sloppy. And I'm going to multiply. Okay. So I don't really want to take half of 5 because that's going to give me a decimal. So I'm going to go 14 plus 6 is 20. 5 and then 1/2. So I'm going to take 1/2 of 20 because that's 10. That's much easier. And then 5 times 10 is 50. So this one I would have 50 square units. All right, let's try another. Let's see if we can find a kite here. Ooh, yay! That worked out so nicely. So we have not done a kite yet. And a kite does have a slightly different oops. I did not mean to zoom out of that. A slightly different formula. So we want to make sure, don't do that. So if we click on here, because I want to make sure I have the formula correct, rhombus. Well, they're showing me a darn rhombus. That's interesting. So they should show us all three, but for some reason they're not showing us that. So the diagonal of a kite splits the kite into 2 congruent triangles. Meaning if I went down like this, if I went into this one, that's obviously, the small triangle, large triangle. What it means is this one here splits it into 2 congruent triangles. If I go down the center of it. So let's see. The area of a triangle, because that's what we kind of want to focus on here. So area of one triangle is 1/2 base times height, like this. So if I can find the area of 1/2 of the triangle, then I can definitely just multiply by 2, right? Because there's 2 congruent triangles. So if I'm focusing on the triangle here, and I'm going to try to, draw it like this. So remember, there's 2 of them here, but I'm going to just focus on one. The height is going to be that perpendicular distance from here over to this line right here, because this is where I'm drawing it. So if I'm at X here for my 1, and I'm coming over to 5, because that's where the line would be on 5, so that means my height is 4. And then the base, well, that's going to be the length that I'm drawing here, the diagonal. So I'm going to go from 5 to -8. Well, I have 5 and then 8 more. So it's 8, 9, 10, 11, 12, 13, right? So my base is 13, and then I'm going to multiply by 1/2. So I'm going to do 1/2 of 4, because that's easier. And then 13 times 2, that's 26. That's not my total area. That's just the area of this one triangle. Remember, I have 2 of them. It's split it into 2 congruent ones. So it's 26 times 2. That's my total area. This was just my area of one triangle. So this is going to be 52. So we went through and did a couple extras there, on the video here, just so that you can see them. It's not necessarily more complicated. It's just the idea you could end up with a kite, a trapezoid, or a rhombus. Any one of those 3. So you have to know how to find the area there. So hopefully this video, helped with that one. And I will see you in the next section.